Wow. Okay. Hello, everybody. It felt good talking before, so I said I'll chat some more. But it's a great pleasure to introduce Juliana from Suricata team, or Jules, as they call her. So Jules is going to do something stunning.
Yeah.
So she's going to add live protocol. She's going to live add protocol, the stun protocol, if I'm not mistaken. Looking forward to the talk and to learn something new, and a big thank you for all your work. Watch out your step here, okay? Because you get up.
Yeah. Hello, everyone. I won't say that it's a pleasure to be here because I would be lying. I'm freaking out. But let's do this. So as Peter mentioned, I'll be adding a new protocol to Suricata, sort of live. It won't be totally live because we don't have a lot of time. So it will be sort of like, you know, those cooking shows where things are pre-prepared. So that's what I'll try to do. And this is going to be fun. So I'll introduce myself, say just a few words about stun because we have to know what we are bringing, right? Then we will get our hands dirty. Then I'll try to show some unit tests. If we have time, I'll show how to create Suricata-Verify tests. Then we will wrap up and have a few questions if we have time. So I am Juliana Fajardini, as I said. I am from Brazil. I am with the Suricata team since December 2020. I joined and come to know about the OISF in that very year through Outreach, an initiative of which I'll be talking more tomorrow with Gail, but I have already started selling it to a few folks here. So if you want to know more about that, feel free to reach out to me. I'm not from InfoSec. I have been in and out of the tech area for a while. So that's one of the reasons why I'm nervous. I don't feel like a pro doing this, but let's do this. I have a few disclaimers. I have already started them. I'm not an expert on stun. I'm not a protocol expert. I'm not from InfoSec, but I'm here to share what I have done with Suricata and during my internship. So I won't know all the answers, and I may freak out a lot. I want to give you an overall picture of what it means to add a protocol to Suricata. So the idea to start, because adding a protocol means a lot, what I did during my internship is to think of an MVP. This comes from the startup world, but it can also work for Suricata. So it would be building a minimum viable app-layer parser. And that would be consisted of the parsers which will be parsing the stream. Then the decoder, which parses communicates with the Suricata engine. And then adding the loggers, because that's where the juicy stuff is, right? And what does that mean? So we parse the protocol messages, reading the stream. We add unit tests. Oh, I don't have the timer. This will be awful. Then we parse, we handle the transactions, which happens during the decoding phase. And once we have that, and we can also add state if you have a stateful protocol. And then we add the logger, and we have this MVP of the protocol. With that, you are already able to generate a lot of important stuff. You don't need to have detection to have something useful for Suricata. You have watched a few presentations showing this, how powerful the Eve log is and how much information you can take out of that. But if you want, once you have that working and you have added Suricata-Verify tests to prove that things are working, you can have what I'm calling a full app-layer parser, which has detection capabilities. So this is the full picture. We will probably just reach the MVP here today, but I wanted to have the full picture visible. And of course, once you have detection, you will improve your Suricata-Verify tests by adding roles to them. And another way of adding detection capabilities, which is coming out with 7, is the frame support. I don't think I'll have time to showcase that, but if you are curious, we have a webinar done by our past outreach intern, Sam Mohammed. She has shown a bit of that, and it's an interesting approach which should make it, rule writers' lives easier. So this is it. I've already done the disclaimer, so let's go to Stun 101. So if you want to add a new protocol to Suricata, you should understand a little bit of what you are adding, right? You should understand the type of transactions that you have, the message format, what types of messages you have. So this represents this step in the process. So the Stun protocol is actually sort of a tool protocol. It's more meant to give developers means of doing this session traversal utilities for NAT, right? I'm reading right there. So it will work with other solutions. It's a client-server protocol. It has basically 2 types of transactions, the request-response one and the indication transaction, which is non-bidirectional. And because it's very simple and it's on UDP, we could even consider that the request-response transaction is actually just unidirectional, so it doesn't have to be bidirectional. So a bit like DNS these days for Suricata. And one important thing is to know the default port for the protocol, because this will make it easier for us to tell Suricata where to look at the traffic if we are not able to detect a pattern for the protocol in the stream. And this would be one way of representing the stun on the network, right? And we have one showcase of where Suricata could be listening, and before we have stun, it will be able to generate a few alerts for stun because of some pattern matching. But after you implement the protocol, then you will have event types for this specific protocol that you have added. An example of the transaction that I have mentioned, and which is the one that we will be parsing today. So it's the request-response one. This is the real format of the message. Don't know if you can see the pointer. So how this looks like on the wire, we have a message type, then length, cookie and transaction ID for the newer versions, and we may or may not have a few attributes. What does this look like in more technical terms, if this is more technical? So we will have first 2 bits being 0, then we have message types, which will be 14 bits, then we have 2 bits this, 2 bytes this, 4 bytes there. And why is this important? Because when we are parsing the protocol, right, we have to know all these details. Otherwise, we are not able to understand what's coming in the stream. And this is the header. And the payload will have 0 or more attributes which have some boundaries, 32 bits boundaries, that we have also to know so we can take care of that properly. And now it's time to get our hands dirty. As I've mentioned, we will have a mise en place of the things that we have to do. I have my cheat sheet here. So what's the approach that I wanted to bring today, and which is the approach that I used for my internship as well? Are you able to see things fine? Okay. Bigger? All right. Let's see if I manage to. I'm just adjusting. Good. The other one. If there's time. Okay. So the approach that I want to use today is the one that I used for my internship, which is using a script that we have that will generate the boilerplate code for one to add a new protocol to Suricata. This was created by Jason-ish, and it had more of a educational purpose, but it can also be adjusted to bring a new protocol in an easier way, because you will know all the steps that have to be done, and you will have all the code both in C and in Rust to make things work. So let's go to the first, what is it, clean. So you start with a clean repo, and then you will use your or our script to generate the boilerplate code, right? So you may say that you want it to be Rust. Actually, you have to, please. We don't accept C protocols anymore, so Rust. Then if you want the parser, you put the options, right? Parser, then logger, and if you want to already add detection, you put detection. Then the name of the protocol that you are adding, the first letters have to be capitals. And if you have detect, you also have to add buffer name. So let's do that now. Let's do that now. Let's not. Let's do that. And simple as that, we will have a bunch of stuff added to Suricata with the name that we have provided, all the changes that have to be done to make sure that the things will link together. We will have the headers, we will have the functions, we will have it added in the Suricata code that needs to have this new information, right? So we have this. Let's just check again the files that were changed. So the make file will be changed for you, lib Suricata or lib. We will have our files added, which will be over here. So all the files that we need for the new protocol will be added as well. Let's go to the next step. Tell me if I'm not making sense, please. Stun add proto. Stun what? Boilerplate? Yeah, so what I've done here is to change, because sure, we have this code and it has the code that was created by the script, right? But we want it to look more like our protocol. So we need what our protocol uses. Is this okay? Is it better if I open like VS Code? Probably, right? Or I don't know. Let's try with so as I said, the first step will be adding the parsers. And in Rust, we will use the known library, because this makes things much easier, because it's basically for parsing string and for parsing data. So it will allow us to create small functions that we can parse small portions of the string and which could be tested right away. So like building blocks, like Lego or Lego. And what I did here, we need to have data structures, right, to represent what stun is. So let's have our stun message representing the fields that I have mentioned earlier. So we have the message type, a payload length, like we had on the wire, a field to represent cookie and transaction, and then our attributes vector, which may or may not exist, so it's an option. And because the attributes also have their own format, let's have this as a type as well. So the attribute type, the length, and again, an optional value. Because we need to respect the constraints for the 32-bit boundaries, we have to calculate if a padding is needed for the messages. And with this infrastructure, or with this code, we are able to parse attributes, which are, it's not, this one is sort of simple-ish. So we have to parse a big endian type, which is U16 for the attribute type, then another big endian type, which will be length, and then the value for the attribute if there is anything, if there is any padding needed, and so on and so forth. Similar for the message. And even if I just had the attribute function, I would already be able to test this. So what I like to do, also to understand that I'm doing the right thing, is to write a short and small unit test to test those small functions, those small parsers. We just get the buffer that we can find from Wireshark, tell what's the expected result from what we are checking, and parse what we have, just call that small function, and compare. Is the expected result the same as the result? Do we have anything left? And this would be it. And if you have written a bunch of unit tests, you just want to do something real quick, you parse, and you check if the result is okay. And this is the quick and dirty way of having something tested. So this is the first step, right? We are parsing messages for stun, which are similar request and response, so we don't need anything different for those two. And we are parsing the attributes. Now, once we have this working and we have it tested, we can move on to the methods, and if transactions is needed, for the decoder part, which would be methods and attributes. I think so. Yeah, I think that's the one. I did it better the other time. So why is it called methods and attributes? I should explain that. Because I'm blipping, just a moment. Because stun has specific message types and specific attributes, so I had to create, I created a toString method to be able to print those in a meaningful way from our logger. Here. This will work, it's fine. Wait. I cannot edit it. Help me. Okay. Nothing to edit. Nice. Let's do the other way around. So I want to show stun. Do we have the methods here? Are they here? I can see properly. I can see clearly now. The rain hasn't gone. I'll go to another branch. Let's. Should be here. Oh, I know what's happening. It's the wrong file. Help. So we want to be able to show in the loggers, in a human-readable way, what do those bytes mean? So we could create a toString method to go over the types that we know that exist, and this can be easily extended if we have an enum, for instance. And because this is Rust, if you have an enum and you have a type that is not covered, you will get an error. So this is also a good reason to be using Rust. And this will not allow you to use a different type here, so safety. And once we have these sorted out and we have the decoder working, now let's go to the decoder. Again, data structure needed. We need a transaction. This could be, here I'm doing request and response, but yeah, it could be just No, I think we have to do it like that, even if it's just unidirectional, and then the difference will be how you tell Suricata to consider a transaction completed. And most of this was also created by the boilerplate code, and what was done here was to change, to adjust to what we need. So we have a state, which is also provided by the script, and then we adjust to what we will need or not. For instance, we don't actually need this. I don't know if I'll break the code, but we don't have gaps because it's UDP. This is also provided by the script, and what we have to change mostly, I still have the gap here, is parsing the request, right? Because we have to know what's the logic in our case for our protocol. Will we handle the error? What do we do if it's not completed? Will we try again? And in some cases, you may have a different approach from request to response. For instance, when I was parsing Postgre, there are a few responses that can be just a single character, so I had to handle this differently. And also I had to take care of the state to know when could I accept that and when that wouldn't happen. For stun, this is much simpler, so I'm not taking care of any of that. Although I still have things that I don't need here. I'm ashamed, but when I submit my pull request, Victor will complain, and I'll know that I should have done better, so it's fine. It's never ready at the first go. And as I said, all the FFI that is needed to connect to the C part or to the engine is also sort of provided by the script, and then we have to adjust to what makes sense for us or not. Again, when I was doing Postgre, at first I wasn't getting anything, and there were two reasons. One was the default port, which I haven't changed. This is the probing parser. I should have mentioned that. One was the default port, as I mentioned, and the other was the fact that we had those messages that could be just 1 byte, right? So when I had an answer, and it was this expected at least 2 bytes, I got nothing, and I said, what am I doing wrong? Everything works. Why am I not seeing messages? And that was why. My probing function was wrong. And with stun, what happened was that I forgot to add the default port, so everything else was working, and I got nothing because Suricata didn't know what to recognize. So we have to pay attention to such details. And in this part, I remember that what I should be showing to you is this. This is one of the most important functions. The registered parser function, which will be created by the script, is where you will connect what you have written and what you have created to the Suricata API, so to speak. So this struct will expect lots of parameters or lots of attributes. And this is where you tell Suricata, I have 4 minutes, oh my gosh. This is where you tell Suricata that what to expect and what to look for. And here is also where you will say what is the default port, if there is one, what type of protocol it is, if it runs on TCP or UDP, if it is bidirectional or unidirectional transaction, and so on and so forth. So this is where the magic happens in my head. And if you don't want to use the script, you just should know that you need this. And up here, we have the name of the parser, which will also be useful. So that said, again, with Rust, you can write a simple unit test to check, for instance. I always like to test my probe function to make sure that I have something that is working. And that Suricata will be able to recognize what the messages look like. And because I don't have a lot of time, I think it's now time to show how things work in practice, right? So things are sort of running here. So what I should do, actually, let's do one thing. Let's go back to Suricata, and let's run Suricata. Not Suricata update. Aren't you working? Source Suricata. Please don't kill me. This is going to be fast, I hope. I just want to show how things would look like without the protocol, right? And then we will go back. Oh, great. No. Let's see what we have in terms of logs here. I don't see that. Oh, it's there. I'm not panicking. It's fine. All right. So we have somewhere where I can easily look at. So this huge, awful log, if we search for stun, we will have an alert, as I mentioned earlier, because there's something that is not traditional here. So this is triggered by the, I believe, yeah, the ET set will have some pattern matching to recognize that this is weird, but we will not have, not that. We will not have anything else related to stun, because Suricata doesn't recognize stun yet. Pattern matching might do that, and that's why you get the alerts, but not Suricata itself. But if we do something similar here, yeah. I make weird sounds. I'm sorry. Is the temp log here? It is. This is an awful way of showing it, but sorry. But here we have not this, not that yet, but you see that we already have something, right? Now Suricata says, this proto is stun. It's not just the alert anymore. And going. This is awful. I should have done better. Let's. Oh, it was there? Thank you. You caught it. But I could also, let's do if box. If now we go to ifbox localhost, we should be able, let's go ifbox. We have a stun event now here. So I was not able to show how the logger works, but yeah, because of the time. But we are only able to see things here because we added the logger. So make sure to do that step if you want to see things. And just to wrap this up, key points, the one-liner to have your new protocol kick-started. Then, of course, registered parser. Don't forget your probing function. There is another way to do it as well, which is using some pattern matching functions. Remember to add documentation if you want this added to Suricata. These days, we will not accept a new protocol without having the entries in the user guide for the new protocol. Remember to polish. So if you are doing this, change the copyright years, add your name, add some documentation as well. Add Suricata-Verify tests. This is also a one-liner to make it work with the CREA test PI script. Remove the log notices, otherwise your pull request will be rejected. And if we have any time, questions are welcome. I'm not hiding. I'm just getting my water.
Thank you for your talk. One question, is there a limit, is there any limitation on the type of protocol that you can include?
What do you mean?
So you said there is, it has to be bidirectional or unidirectional, and what you did is a UDP. Let's say, for example, I want to add a quick protocol, which probably is not official, so to speak, but Google is using for a lot of different things.
We have it.
Okay. I was just giving as an example, but is there any limitation on the type of protocols that you can add? Because there's a lot of IoT, industrial IoT kind of protocols that's not very common, and it's not typically included. So let's say I want to add some of those. Are there?
We have, for instance, Modbus, right, which is more industry related, which was actually the first protocol that I should be working with for Suricata, but then someone else was also doing that. So the first thing I would tell you is that if you want to add a new protocol to Suricata and you want this to be accepted to Suricata, you would should talk to us first and learn if we want it, if this makes sense to us, if you would be able to work on it, because otherwise it's unlikely that we will be able to maintain it. So this would be the first step. Talk to us first, know if there isn't anyone else working on that. And then if it's something that you want to add as something private that you won't be sharing with us, I cannot think of a limitation. I could be wrong, and then Victor and Jason and Philip would be the folks to answer that.
I guess the limitation is that we use U16, so we can have maximum 65,000 protocols, but we have only 30, so the limit is far for now.
I think another limitation that was brought up yesterday is that currently this only works on top of UDP or TCP. So protocols that do not fall in that category would be a lot harder to add, and you would probably need to make lower level changes first.
Sorry. I'm breaking things.
I will give you a second. Oh, hello. Hi. I was just wondering if there was documentation on all the scripts, the helper scripts that you had, or do you just have to dig through the script directory and kind of figure out what you should be using?
I actually found them by accident, at least the setup player one.
Okay, because I've been spending the last 2 days writing a parser, and this was way helpful. So.
I should be finishing a blog post on that soon. There is documentation for the create test one. The README on the Suricata-Verify repo will give you 2 examples, I think. Excuse me. And for creating the protocol, I should finish that blog post now, I guess. Thank you, folks. Sorry if it wasn't as live demo as expected, but I'll try to do a webinar on that, or maybe a few.
Wow. Okay. So I have to share a post that was put in our team chat that if you hadn't said it, this audience would never have known you were nervous. So you did an excellent job. Well done, Juliana. Thank you so much.
Thank you.